Hey guys, how's it going? I'm back here with another video, and today I decided to actually start a series where I'm going to be teaching you guys how to build a CRUD application using TypeScript, GraphQL, React, NodeJS, and MySQL. So basically, these are probably the main technologies that I use in a side project nowadays because I really love the combining them together. So that's why I decided to bring this video, because a lot of you guys have been asking me to make a little bit more complicated videos. However, I know that complicated videos take a lot of time. Also, they won't be applicable to everyone. So what I decided to do is I'll try to get all the important technologies that I use nowadays that are considered a little bit harder and try to condense them into a very simple and beginner's tutorial like making a simple CRUD, right? So basically, in this video, we're going to be building a very simple application which will have a front end which will be made in React and a backend which will be made in Node using MySQL, TypeScript, everything, right? So let's actually already start dividing our project, as you can see right here. I'm going to create two folders. The first one is going to be the client, and the second one will be the server. And the reason why I do this is because it makes it easier for deployment later. So we keep our client, our React application in our client folder, and we keep all of our server in our server folder, right? So now we're actually going to focus in this video on working with the server first, because I think building the API makes more sense in the beginning. So what I'm going to do is I'm going to open up here the terminal, and I'm just going to change my directory towards the server so that I'm at least inside of the server, and everything that I install through my terminal will be inside of my server folder. And now that I'm inside here, I'll just run yarn init, and this will be actually a command which will start by initting everything, as you can see right here. And you can see that a package.json will actually appear in my screen. However, as I mentioned before, we're going to be using TypeScript for this application. So I'm going to actually show you guys how to set up TypeScript, but I won't focus that much because I've already posted a video explaining exactly this. Basically, what we have to do now is we're actually going to come inside of here. We're going to create, run the command tsc and two hyphens like this, init. And you'll see that it will create a tsconfig file in our application, which is really nice because it is exactly what we want, right? So what we want to do now is we want to start installing some packages. First, I will actually install all my TypeScript packages, which is kind of annoying, but it's something that you have to do. So I'll actually install TypeScript over here. Then I'll install tsnode. Then probably, let me think. Probably Express. I actually just started installing some of the major packages. Then Express will obviously serve for creating our API. I will install cores, which is basically a package that will allow us to create a connection between our front end and our backend. And for now, let's also just install as well Node1, which will be a package will allow us to run our server, and at the same time, every time we save some changes, it will automatically restart our server. When we click install, you can see it will start installing our packages. And obviously, if you're using npm, you can just run npm install instead of yarn add. And when it finishes installing, I'll come back to continue the tutorial. As you can see, we just finished installing those packages. We will definitely install more. For example, actually, I'll just install some of the type packages because we will be using some types because we're using TypeScript. So I'll actually install all the types related to cores, which are important because we're going to be using cores. Also, all the types related to Express and all the types related to Node. So what we're doing right here is we're just setting up TypeScript to work in our application. When this finishes installing, actually I don't need to wait for this. We can just start building our application, right? So what happens is we now have here our tsconfig, our package.json, and everything seems to be okay, right? However, we need to start configuring some stuff for our tsconfig. For example, let's change this to be ES6 because we want to we want to specify our TypeScript to satisfy newer versions of JavaScript. So ES6 is better than ES5, right? So then what we want to change is, remember that if you have a TypeScript application, your code won't be outputted as TypeScript because no browser will understand TypeScript. It will actually understand JavaScript. So what happens is we have to put here a file that will actually represent our a folder that will represent where our server is running, and a folder where it will represent where our project will be built. So what we do is we actually come over here and we can create a folder called dist, for example. And what happens is every time we run our application, or at least when we run some commands to build, it will compile all of our TypeScript files from our root directory. I actually should have done it over here like this. I should uncomment this. It will compile all of our TypeScript in our root directory and put it into as JavaScript in our output directory. So let's create here two folders. One will be our output folder, our build folder, which will be the dist, and one will be actually the folder where we're going to have our whole application in. So it's going to be the src, as you can see. And in our output directory, I'm going to call it dist, as I mentioned. It's right over here. And in our root directory, we're just going to put src. And this should be fine. Now, what we can do is basically we can just set up some stuff so that it will help us in the long run so that we don't have any issues with our types. One thing that we can do is we can just say that we want to set strict property initialization to be equal to true. Also, module resolution to be equal to node. This is extremely important. And maybe we can add decorators to our application. So let's uncomment both of this. So these are all just configuration files and configuration things that we can put in our TS config. They're completely optional, but it will work better if we do it this way. So now that we have this kind of done, what we can do is we can close this and we can start by creating our actual project, right? And you can see that we actually have here our packages. However, we're going to be installing more packages and we'll also be focusing on creating our scripts for our package.json. So for now, let's actually install our packages. Let's come over here and let's think about this. What exactly are the packages that we want to install, right? We already have, as you can see right here, we already have cores, we already have Express, we already have NodeJS, we have all of these things, but our application will actually run on a GraphQL API, and we're going to be using MySQL as our database. Not to mention, one technology that is extremely important to have when you're passing from the beginner phase to intermediate is an ORM. What is an ORM is basically a library that will allow you to write, convert objects and JavaScript into SQL queries. And in this case, I'm going to be using a very famous library, which I actually have a video on, called TypeOrm. And it is a really cool library. I'm just going to add it into my application. I'm going to install TypeOrm, which you guys will see exactly what it does. It will make SQL statements very simple. So we're going to add TypeOrm. We're going to add MySQL, and I will use MySQL 2 just because it is a lot faster than MySQL. They're just like the same thing, but MySQL 2 is faster and it's more adaptable for newer versions of JavaScript. And then we'll also install GraphQL and express-graphql, which is actually the GraphQL server that we're going to be building. There are many packages that help you create a GraphQL server. However, express-graphql, in my opinion, is one of the easiest ones to begin with and also one of the best ones to use overall. So this is actually, I believe, all the packages we're going to install. So I'm just going to press enter over here, and this should be fine for now. But we also need to, while they're installing, we need to make some changes to our package.json so that we can set up our application to run smoothly. And the last thing we actually have to do is we actually need to insert a scripts tag over here, just so that we have all of our scripts, right? So the first one we're going to have is we're going to set up a start script. So the start script will actually run the build version of our application. So it will run the index.js inside of our dist folder. So I'll just say node./dist, and it will have an index.js inside of here because we're going to create one, right? And then we're going to have a dev, which will be just the one that we're going to run mostly, which is actually just, we're going to run NodeJS inside of our application, and we're going to run the file, the index.js, actually not JS, TS, because we are using TypeScript. So inside of our src folder. And this will be the one we're going to be testing, right? And then if we want to build our application, we can just run, create a build command and just run tsc and put the p flag and a dot at the end. This, as I mentioned, I explained thoroughly on my how to install and create Express APIs with TypeScript. So I won't be going too much in depth. However, the link for that video is up here or in the description, right? So I'm going to close this package.json because this is basically it for it. So I'm just going to come over here to my src, and I'm actually going to create our entry point to our application. And if you recall, we call this entry point the index.ts, which is actually what I like to do, right? I like to use index.ts as the main point. And inside of here, we're going to write all of the initial steps to our application. So what do we want to do first? Well, now that we have TypeScript and we configured it so that it applies to newer versions of JavaScript, we can actually use the import statement, as you can see, which is something that we couldn't do usually without TypeScript. So now we can come over here and import express from express, as you can see. And then we're going to import some stuff from express-graphql, which basically will allow us to actually initialize our express-graphql server. And what we're going to import is GraphQL HTTP, which is basically the middleware that we're going to be applying to create our server. Then we want to import cores, obviously, which will allow us to connect our React to our GraphQL. And then we're going to import createConnection, which is a function that exists in TypeOrm, which will allow us to very easily create a connection between a database we're going to create in our computer and our application. So these are the things we're going to be importing for our kind of like our main file, our entry point to our server. And what I like to do is whenever I'm doing an application that is a little bit more advanced, I actually like to create a function which is going to be actually the main starting point of our application, and it will be asynchronous because I want to run all of our configurations asynchronously so that we have no issues in regards to that, right? So inside of here, it's going to be a simple function which everything from like connecting to our database to applying all the middlewares and listening to our server will all be done inside of here. And at the end, we'll just call the function like this. And if there's any errors, we can catch the error like this. We can just say catch error, and for now let's just console log if there's any errors, and that's fine. So this is going to be kind of the structure of our application. And inside of here, we're going to put basically we're going to create our app by saying const app equal to express. So we're going to create an instance of express so that we can apply all the middlewares and also tell our server to listen at a certain port. And we're also going to use this to apply the GraphQL middleware. So we're going to do everything inside of our main function. And then what we can do is we can come over here and say app.use cores, which is the first middleware we're going to be applying. And as I mentioned, cores will just serve as a way to connect your front end, your React client, to your backend. And if you don't apply cores, you're going to have a lot of errors when you're making your requests. So just apply this library. It will work perfectly. So then the middleware we're going to use is basically just a middleware created by Express, which will allow us to parse all the JSON that are sent in requests. If that sounded complicated, it basically means that we're going to be using JSON as the body to every single HTTP request sent to our server. So that means that when a client sends data like username, passwords, that kind of stuff, we're going to be able to parse the JSON and receive them very easily in our GraphQL server. So then what we can do is we can actually start applying our GraphQL middleware. And this is actually most of the configuration we're going to be doing to actually make GraphQL work. What you have to do is you have to say app.use to apply middleware, and you have to pass two things. If you're unfamiliar in regards to how GraphQL works, basically we don't have many endpoints. You actually just have one endpoint. It's going to be your API/GraphQL. That's going to be the only endpoint where you're going to make requests. It's like this. And that's fine because this is all you need. We're going to be applying the GraphQL HTTP middleware, as you can see. And inside of here, we can actually pass two pieces of information. One of them is a schema, and the other one is just GraphQL, which I'll explain what this means. Basically, graphical, which is how you say this, is just a very easy, very simple API tester provided by express-GraphQL. It will appear like when you reach this endpoint in your computer, in your browser, it will show a beautiful interface which we're going to be able to test our API. I'm going to show you guys exactly what I mean by that. But as you can see, our schema is currently giving us some errors. And that's totally fine because what even is schema, right? We haven't created anything called schema. And that's why for now we're going to uncomment this. This over here will only be done when we finish up setting up our queries, our mutations, and actually creating our type definitions for our GraphQL schemas. And that's totally fine. We don't need that for now. What we're going to do actually is we're going to come over here and we're going to say app.listen, like this, app.listen. and we're going to pass here a port, which is, I think our server should run on port 3001, and a function which will basically just say something like console log server running on port 3001, something like this, right? And basically this should work. We should actually start by creating our main function. It is an asynchronous function. It should run all of this. It should tell our app to listen, and then we should call this main function and catch if there's any errors. So let's actually test to see if this is working. I'm gonna run here yarn dev, as you can see, because this is the command we should run when we are in development, and you can see that it actually should start running. There isn't any messages saying server running. Okay, it just appeared here, and you can see that everything seems to be working. If we go to localhost 3001, it shows cannot get slash, which means our server is actually running and we configured our TypeScript application correctly. But now, what do we do, right? We actually don't have our GraphQL schema ready. We actually don't even have our database set up. Remember, we imported this create connection from here, but we actually didn't set up anything. Well, I'm going to show you guys exactly how to do that now. What happens is, in this tutorial, I'm going to be using MySQL, but you can replace MySQL with anything. So you can see in the timestamps down below that for now I'm just going to show really quickly how to set up a table and using MySQL Workbench. However, if you're using MongoDB, if you're using whatever, don't worry, just skip to the next part and don't worry about the code. I'm just going to do some MySQL setting up right here, and whenever we use some MySQL queries, you can just replace by whatever database you're using. Okay, so to connect TypeOrm and MySQL to our application, we have to first create our database in our local computer. So I'm not going to be showing exactly how to install MySQL, how to do all of this stuff. I have literally videos on that if you want to check out. I'll probably link it in the description as well. But I'm going to be using a program called MySQL Workbench. If you want to use other programs that help you visualize databases, you can use. There are several of them. There's PHPMyAdmin, there's SQL Pro. I like to use MySQL Workbench because it's the first program that I used and I sticked with it, right? So basically, I'm just gonna enter into my local host over here, and I'm gonna create a database in my local instance by clicking on create schema right here and going over here and generating a schema name called let me call this GraphQL CRUD. I'll name it this, but you can name it whatever you want. It's just the name of the database, which is going to be really important when we make the connection to it in our application. So I'm going to click on apply, and you can see that it will create a schema over here, and we can just click apply again, and it will actually create the schema down here. Somewhere here, yeah, right over here, you can see the database appears in our screen. So we can right click on this, and you can see that a bunch of stuff appears, but most importantly, there's a tables part over here which doesn't have any table in it. It's completely empty, and that's completely fine. The reason why that's fine is because we're gonna actually write the table in our in our code, and it will automatically generate this table when we run our application. So let's actually start doing that. We just created our database. It's called GraphQL CRUD, and that's fine. Now what we have to do is we need to use this create connection variable from TypeOrm in order to create the connection to our database. So we're going to come down here, and the first thing we're actually going to do in this main function, it's actually going to be the create connection. So we're going to use the await because this is an asynchronous function, and we're going to say await create connection. And inside of here, we can pass an object that is going to represent like all the connection details to our database. The first thing that we have to pass is the type. So TypeOrm works with every single, like most types of databases. You can see it works with MongoDB, it works with Postgres, Oracle, even with like everything, right? So what we're going to be using is MySQL. So we're going to put over here MySQL. You put the type that you want to over here, and the rest should be actually pretty similar. And then we have to pass the database, and the database is just the name of the database you created. I called my GraphQL CRUD, as you recall, and you should put it exactly how you named it, or else it won't work. Then you have to pass a username, and initially, if you're running a local instance, like a database in your computer, it should probably be root, but you should check that. It's usually root, so just try root. If it is not, then you probably changed it. Then password, if it's your first time doing this, it should probably be an empty password. Or if you changed your MySQL password, that's pretty easy to do. I changed mine to password, so that's what I'm going to be putting over here. But you can put but usually it starts with an empty string. So if it is your first time doing this, just put an empty string. Then we can put 3 more properties to this object, and they are very essential to how TypeOrm works. The first of it is logging, and logging is actually really cool, which means that whenever TypeOrm runs an SQL statement, it's going to log the SQL statement, so we can clearly see what it's doing on the backend. We're going to be using its several functions to create our stuff and to make our statements. However, we are also being able to see the statements being generated throughout this logging property. So we're going to set it equal to true. You can set it equal to false if you think logging every SQL statement is annoying. I actually like looking at it, so I'll just set it equal to true. Then we're going to pass this synchronize. Basically what happens is, I'll just set it equal to false, and I'll explain what happens to it after we pass an entities over here. So we're going to pass entities. And basically what happens is, every table you create, you need to create a file called entity. And this comes with TypeOrm. For example, we're going to have a table called users. Let's imagine we're going to have one, which I think we should probably create one. I think the example we're going to use for this tutorial will probably be like a user, kind of an application with a user where you can create users, update users, that kind of stuff, right? So what we would have here is every single table we have in our database, we would basically pass inside of this array. And for example, if we had a user table, then we would create our user entity, and I'm going to show you guys how to do that. And we would pass it over here, and if synchronize is equal to true, it will automatically check all tables or all entities in this array and create them in our database. So what it means is, we will generate the table by code, and it will, when we set synchronize equal to true, it will automatically generate it in our actual database, which is perfect, right? We don't need to actually create the database inside of our MySQL workbench. But initially, I'll set it equal to false because we don't have an entity yet, so that's fine. And we're not even going to pass any entities. Let's just set this as an empty array, and this should actually work. This right here should establish a connection to our database, and we won't be seeing it for now because we actually need to start setting up some stuff. However, this should be fine. What do we want to do now? Well, we want to actually move away from MySQL stuff because I want to show you guys how to actually start setting up our GraphQL part of the project, right? So what exactly do I mean by that? Well, I'm going to open here a folder, and I like to call this folder schema, but you can call it whatever you want again. And inside of here is where we're going to have most of our GraphQL code. I'm going to divide this into 3 parts, and I'll explain what each one of them means. But basically, we're going to divide this into a folder called Mutations, then a folder called Queries, then a folder called Type Definitions, so type defs, like this. And overall, we're going to have inside of the schema a file called index.js, which is going to be outside of all the folders. So as you can see right here, we're going to have a schema, which is a folder, and inside of it there's going to be mutations, queries, type definitions, and index.ts. So for those who don't know how GraphQL works, basically there's 2 types of operations you can make in regards to your data. There's a query, which it's kind of self-explanatory. Basically, queries are everything, like every operation, every request in which you want to get data. So when you think about CRUD, you think about create, read, update, and delete. So queries will be the read, and mutations will be the create, update, and delete. So basically, queries is just the read, and mutations is the rest, right? So it's just a way to it's just how they call it, but we can create mutations and queries. So everything related to the like CUD in the CRUD we'll put inside of the mutations folder, and everything related to the read we'll put into the queries folder. And this will become more apparent as we go through, but I just wanted to show you guys what it means, right? And type definitions is basically a folder in which we will store our types. And what do I mean by that is, for example, imagine that I want to write a query which is going to return every single user in our database, right? That makes sense. However, think about this. When you create a query, it should return a list of all users, and each user should be an object containing an ID, a name, maybe a username or an email, and a password, something like that, right? So we have to specify in GraphQL what will be the return type of every single query. So in this type definitions folder is where we actually create that. So this is actually the first thing we're going to be creating for now, which we're actually just going to create a file over here. And what I like to do is I like to create a file for each table or for each type that we're going to have. So we're going to have here user.ts, which is going to be probably the only one we're going to create. I'm not going to create many tables. It's just user.ts. And over here, we're going to actually start defining our GraphQL schema for the user. So to do that, we can just come over here and first of all import, as you can see. We're going to import some stuff from GraphQL. Actually, I'm going to say from GraphQL over here. We're just going to import some types that already come with GraphQL. So this is why we downloaded this package, because it provides us with different types that exist in the GraphQL library. So for example, we're going to import GraphQL object type, which is important to create a type for that's how you create a type, for example, user. And then we're going to use probably GraphQL ID, like this, and probably something like GraphQL string, and I'll explain what they mean. So what happens is we're importing those packages, and now we can actually create a user type over here. I'm going to say export const user type, and it's going to be equal to new GraphQL object type. So GraphQL object type, and we can pass inside of here an object containing all the definitions within this type. And the first thing we have to pass is actually just the name of the type, right? I'm gonna call it user like this because it's very simple, just looks good. But then we also need to pass all of its fields. And what do I mean by these fields is basically just an object like this. This is the syntax. An object containing all of the different columns that we will have in this user type. And what exactly are the columns we're going to have? Well, first of all, we're going to have an ID, which is why we actually imported the GraphQL ID over here, because an ID will be of type GraphQL ID. They have a type specifically for ID, so that's great. And to define its type, we can just pass over here an object and then say type, and then pass the type like this, GraphQL ID. Perfect. And then we're going to have, let me say name. I'm just making this up on the go, but we're going to have a name for our user, and its type will be GraphQL string, like this. And then I'm just going to copy this because we're going to have username and password, which are two fields that are also going to be strings, so that's fine. I'm just going to make this equal to user name, like this, and this will be equal to password, like this. Okay, so that's fine. You can see we already defined our user type. And now we can use this whenever we want to make any queries or mutations related to the user. And you guys can already see that this is how I'm going to create my table. I'm going to create my user table to have only ID, name, username, and password, because I don't want to overcomplicate it. It's just a simple table, as you can see, containing information about a user in an application. So I'm going to close this tab over here, because now we're going to be focusing on our index.ts. So why did we create an index.ts file right outside of every single folder over here? Well, because this is actually going to be where we're going to export our schema. Remember that in our index.ts, the original one over here, where we have the schema variable over here, this schema variable will represent all the schemas and all the operations, all the queries and mutations we're going to have in our application. So what is going to happen is in this index.ts is where we're actually going to create those schema and export it so that we can access it in our main entry point of our server. So we're going to come here to our index.ts, and we're going to basically divide this into three parts. So at the bottom here, we're going to, obviously, as I mentioned, export a variable called schema, which we're going to import in our main entry point of our application, and it's going to be equal to new GraphQL schema, which is actually a type that we haven't imported, but I think it will automatically import from GraphQL, as you can see right here. And a GraphQL schema contains only two pieces of information: a query and a mutation, as you can see right here. A mutation, like this. I just had to put a comma over here. And obviously we don't have any of them, but we don't have the query and the mutation, but I'll explain what they mean by now. So we actually have to create that query and the mutation, which basically is just a GraphQL object type, which will contain all the queries and all the mutations we might want to have in our application. So for example, for the query, I can just create here root query, and this will be equal to new GraphQL object type, pass here like an object inside of here, and this object will contain a name, as we did before. I'll call this object root query, which is what I usually like to call the main query object. And then inside of here we can pass some fields. So the fields will basically be all of the queries that we might want to have in our application. So as we make them, we're going to put them inside of here as like properties in our object, right? And then we also need to create the main mutation. So we could call it root mutation, or actually just call it mutation usually, like this. Mutation. Sorry about that. Mutation. And it's also going to be a GraphQL object type. I'm going to change this to mutation. And it's also going to have some fields containing all the mutations we want to have in our application. So basically we'll just grab both of them and put them inside of our schema, and this should be it for our schema. Basically this was what we're going to be exporting, and now in our actual like entry point of our application we can actually import this here at the top. Import from ./schema. We're going to import from schema, so we're going to import the variable schema, which comes from here. As you can see, we're exporting const schema, and now we can uncomment this and our GraphQL server should be working. You can see we're using the schema variable that we imported, and when we save this it should be working. Let's check to see if our GraphQL is actually working. To check that, I'm going to refresh this page. You can see it's still working, but let's go to the /GraphQL route and let's see if the GraphQL API tester appears. You can see it appears beautifully. I'm just going to delete this. This is from another project, but basically you can see we now have this beautiful interface where we can actually test GraphQL API requests. So this is perfect. This is what I was talking about with this graphical thing over here. It's a beautiful interface where you can actually test it. It's similar to like Postman or Insomnia if you've ever worked with them. You can just put queries over here and it will actually work with your localhost. So we can see it's working, but we still need to actually create the queries and the mutations. So I'm actually going to come over here to our queries and mutations folder, and for each of them I'm actually going to create a single file called user.ts for both of them. So both of them will have a user.ts, because imagine that you want to have many tables in your application, you want to have many different schemas, many different types, and you don't want to write queries for different types and different schemas on the same file, right? So inside of this mutation folder, a way that you can organize it, I'm not saying it's the most organized way, is by basically creating a file for example, inside of the user.ts, it will be all inside of the mutations, it will be all mutations that mutate the users table, right? Inside of the queries for user.ts, it will be all the queries where I get information from the user table. So that's basically what I did here. So I'm just gonna close everything and just keep both of the mutations and the queries file open. But first, let's actually start with the queries. Let's start writing some queries in our application. So what are we gonna do here? Well, to write a query, it's actually pretty simple. You can just come over here at the bottom, and I'm gonna export const because we're gonna have main queries here. So each query that we want, we can just export them like this by saying export const, and then just putting the name of the query over here. The first query we might want to have is something like get all users. I remember I just saw that over there. It makes sense, right? Let's just create a query that return all users. And usually when you write queries like this, I don't know why, but it's standard to just write the name of the variable for the query or for the mutation in all caps lock like this. And over here, to create our query, we can just pass inside of this object some pieces of information. For example, we have to pass the type. So let's think about this. Remember when I said that we have to put here for the type what we're returning, right? So think about this. This is a query wanting to return all users. So what would we want to return? Well, we want to return users, right? So remember that we created a user type. We can now import from actually I'll have to go back twice and go to type definitions /user maybe, and just grab, let me see, user type, I think, yeah. So we can maybe come here and say, well, the type is user type, right? Because I want to return users. However, think about this better. We want to return all users. So what if there's two users? So that isn't actually just a user type. That is a list of users. So in GraphQL, when you want to return a list of a type or a list of users or a list of strings, whatever you want, you actually have to wrap this around with new GraphQL. I'm just going to do like this, GraphQL list like this. It will automatically import here at the top. So we're just gonna wrap this around with a list, and basically what this means is we want to say that return type will be a list of users, or at least a list of user types, and then we're gonna put a comma over here, and we have to pass a resolver. So for every query and every mutation, we have to pass a function called resolve, which basically will be a function where we do all of the things with our data. So where we actually make the query to the database, or whatever we want to do with our data, right? And we're using TypeScript here, so we can obviously put some types. For now, I'm just gonna put void, or actually no, I'll put maybe string, like this. Oh, what did I do? I'm gonna put string, because we're just for now. Let me see. It's neither void or any. Oh, because we need to return something over here. For example, imagine we want to return the string Pedro, right? I know that this doesn't make sense because we're not actually returning a GraphQL list of user type, but we can test to see if this is actually working. So how do we do this? Let's get here to the top and in our index.ts, and let's import this thing over here. So import equals to, we're gonna import from, not equals, so from /queries, we're gonna import from the queries /user, like this. And from here we want to import the get all users. So to actually test if this query is working, we go to the root query, and where it says fields, we can just first of all pass a function which will be used to basically, whenever you want to run this query, you call this function. So we put here the name of the function. So let's call it get all users. And then we pass the query that we created over here. And now you'll see that not only does this should work, I mean like not crash, but also it should also give us some autocomplete. For example, I'm inside of here of my graphical. If I want to run a query or test a query, usually what you do is you write query over here, and then open and close curly braces, and put the name of the query inside of it. So it should start autocompleting. It didn't, but let's do it anyway. Get all users, and then over here inside of this, we can actually pass all the different things that we might want to receive from the users. But for now, it shouldn't be anything. So let's just run this. You'll see that type mutation was defined. Oh, okay, because we haven't actually created any mutations yet. Okay, that's fine. So okay, so that's fine. Let's come here and just continue. I just wanted to show an example to you guys, but I think it's better actually to just continue and try to actually integrate our database into this. But for now, let's just think about this. We're going to be returning a list inside of this. So for now, let's just put a list like this, right? Just so that we can create a mutation first. And the reason why I'm doing this is because we haven't actually added anything to our database. We actually haven't even created our database table. So that's completely fine. We're not going to integrate database right now. We're going to integrate after we create our first mutation, and then we're going to change our values inside of our resolve function so that it satisfies, like it actually makes queries to a database. So now let's come here to our mutations, and what we can do is we can actually just come inside of here and create, similar to what we did with a query, we can create a create user mutation. And it's going to be very similar. We can pass a type, but think about this. Like when we run a mutation, when we run a create statement or a create request, we usually don't even care that much about the return type, because honestly, like, why would we? We're just adding stuff to the database. We're not asking anything bad. But however, if we want to, we can pass, like, we can return back a user. So the user that we're trying to create, we can return back, right? And here, we can actually pass some arguments, because think about this. We want to create a user to the database, so we actually need to pass some arguments inside of here, because how would you not pass arguments? You need to pass arguments so that it will be inserted a new user into the database, right? So let's think about this. What are the kind of arguments we want to have in our application? So with the create user, if you recall, we created a type definition here called user.ts, which we said that we only want an ID, a name, a username, and a password. So for the create user, it makes sense to only send a name, a username, and a password, right? That's enough to add to the database. So we can come here to the mutations, and we can say that I want to have a field or an argument called name, which will be of type GraphQL string, right? And then I'll just copy and paste. Actually, I can just copy and paste. I'll just grab this right here at the type definitions. I'll literally just copy and paste this because it's literally the same. We just want to say that for the arguments, we want to have exactly this, right? We want to pass a name, a username, and a password as the argument to this mutation. And then over here, we want to have a resolve function. Similar to the query. We're going to pass a function over here, which in this case, which is kind of different from the query, we need to find a way to grab these arguments that we passed here, right? We're going to pass this as an object, but how do we know exactly, how do we get the arguments so that we insert them into our database inside of this function? Well, in the resolve function, we can get arguments inside of it. So for example, we can get our parameters, that's what I meant. So we can get a parent, we can get args. This is kind of the order, right? However, there's many things you can get here. However, the only important one for now is just args, because it's actually the type that we want to. And honestly, to not overcomplicate, I don't want to pass some type. I don't want to. We're using TypeScript. However, I'll just pass for now any for both of them because I don't want to deal with interfaces, that kind of stuff. And we're just going to use them right now so that we can get this argument out of the way. So now if we want to access, for example, name, username, and password, we can do something like this. We can set const equal to args, and args will be an object containing whatever we passed as the name, the username, and password to this query, or to this mutation. And we can grab name, username, and password, like this. And over here, we obviously can just create the mutation and make it work, right? Just inside of here, we can write the insert statement, which would insert into our database, which we're not doing for now. I'll just try to test the query first, and we can see if it's working, and then we're gonna integrate TypeOrm and the MySQL database into our application. Actually, I decided to just integrate it right now because I think it will actually be more beneficial. You can see that for every mutation of query, we need to return something. I said that we are returning a user type, so we need to return an object containing a name, username, and password. Let's just return args because that's an object containing username, name, username, and password, right? It makes sense. So I'm just returning whatever the person sent back to the to our request, right? So that's basically it for our mutation. And obviously, as we did before, if we want to like access this mutation in our index.ts, we can just copy this right here and paste it over here. Change this from queries to mutations and change this to create user. And now we can come here to our mutations and pass a create user field over here, or function, which will be equal to create user, like this, right? So this is basically it for our GraphQL structure. We've went over a bunch of stuff from GraphQL, and now we're going to be focusing on how to actually make the queries to our database. You recall that I created the database, it made the connection, however, we didn't create the table. So how do we do this with TypeOrm, and how do we make that table work, right? So to do that, we can just come here and create a folder in our SRC. Let me just create a folder here outside of my schema, a folder called entities. And this is just a folder which you're going to store a bunch of files, and each file should represent a different table in your database. So obviously, I'm going to call this user.ts or users.ts. Like this, users.ts. It's going to be where we're going to create our users table. So I'm just going to just close all of these tabs. And for now, let's just open up here the user, the entity, right? So here we're going to be writing some TypeOrm code. So for that, we have to think about it this way. With TypeOrm, for every single like table you want to have, you need to create a class. And I'm going to export this class because we're going to be accessing it in other files. So we're going to create a class with the name of the table. So let's call this table users, right? So it's the users table. And then you have to say that this table extends something called the base entity, which means that we are actually creating an entity. And you can see that it will import everything we type here automatically at the top of our file. And then we pass it like this. And what happens is, first of all, obviously MySQL doesn't take capital letters into table names, so this will be translated. It will create a table called users, but it won't have the capital letter. So whatever you put inside of here should be the name of your table. So don't put something random. And another thing that is important is decorators. So decorators are basically adding like stuff that you can put to define exactly what you're talking about. So for example, over here we're gonna put like an @ symbol, and we're gonna write entity to signalize that this is an entity. So if you're getting errors with this, let me know in the comment, because I've had issues with operating with decorators in TypeScript, and I can help you out. But for me, you can see it's working perfectly, but I know how unreliable tutorials are, in the sense that maybe it's working for me, but it's not working for you. So let a comment down below, and I'll definitely answer you. So for every entity, we have to pass the decorator at the top saying entity, and you can see that entity has been imported from TypeOrm. And now we can pass all of our columns that we want to have in our table. And to pass a column, you just have to pass the column decorator like this, and it should have a parenthesis at the end. And at the bottom, you just pass the name of the column, which is name, for example. That's a name that we want to have in our table, and the TypeScript type. So a name should be a string, right? And also you need to put an exclamation mark so it doesn't give that error. So this is the format, right? For every column, you just put the decorator, name, you put the exclamation mark, and the type. So we're going to copy this 3 times, because you guys know that we have 3 columns in our database. We have name, we have username, and we have password. But we can't forget about creating the ID, right? Because every MySQL table or any other SQL table usually have an ID. So what do we pass as the decorator for the ID? Do we pass column? Well, actually no, because we want it to generate automatically. Every time you add something to the database, to the table, you want it to create like increment ID by 1. So TypeOrm already has a really nice decorator here called primary generated column, which will automatically do that for you. And over here we can just pass ID and say that it is a number, like this. And obviously we need to pass the exclamation mark right here. And now this is literally it. We can create more columns if you want to, but that's basically fine. We have our entity over here, and we are exporting it so that we can access it in different files. So where do we want to access this entity? Well, remember what I said. In our index.ts, there's an entities array which we haven't put anything yet, and obviously it has like synchronize is set false because we don't want to we don't have any tables to create yet. So what we can do is we can import from entities like this, entities / users. We can import. I accidentally got out of hand. So users, we can import the user like this, the users class, and inside of this entities array, we can just pass users. And now what happens is whenever we set synchronize equal to true, and we save this, I haven't saved it yet, but whenever we set synchronize equal to true and we save this, it's going to go over all the entities in the list of entities over here, and it's going to try to run an SQL statement to create all the tables inside of here. I'm going to open up my SQL workbench, and as I showed to you guys, you can see we have 0 tables in our database, right? But when I save this project, what should happen is it should actually, and I'll even open up here my terminal so you guys can see, because we set login equal to true. So it should appear an SQL statement here for creating our database or a table, and the table should appear in our database. So let's save this. You should see that it should log. As you can see, it logged a bunch of like stuff, but this is the SQL that is running, right? This is the SQL statement that is running. It's creating our table, and it's, I don't know, it looks really nice in my opinion. So let's check to see if the table was actually created. So to check to see if it's been created on my SQL workbench, you just refresh all, and you can see that now we have a table called users. And if we select rows, you can see that it is actually the entity that we created. It has an ID, a name, a username, and a password. But something that is important is, for some reason, there's some bugs in which if you maintain synchronize equal to true, it will consistently try to create new tables. So I will set this equal to false, and whenever you need to create a new table, just remove the old tables that already exist in your database from the entities folder and set it equal to true so that it creates the tables automatically. So now we have our table here in our beautiful database. So what do we do now? Well, we now can use this together with TypeOrm to make any queries. And you'll see how easy it is to use TypeOrm with MySQL or any other database. Because if you've worked with just the simple MySQL package before, you'll see that it's kind of like how easy it is compared to what you're used to. For example, if I want to make a query that returns every single element in the table, which for now it is absolutely nothing. You can see there's nothing in our table, but let's just try it, right? How do I do this? Well, we can import the users entity. So import from dot slash or dot slash, then dot slash again, entities slash users. We can import users from here, and we can just simply return users dot find. This is literally it. We access the entity and we use built-in functions that represent SQL statements. So with TypeOrm, we can just say that we want to return users.find. And let's test to see if this works, right? Let's save it here. You can see that I'm actually going to show you guys the logging. You can see the last thing that logged was server running on port 3001 because we saved our application. But if we come here to GraphQL, let's try to run a query again. So let's say query get all users, and you can see that it now get all users appear here, which means it's working. And let's say that with GraphQL, what you can do is you can actually just specify what you want to get from each user. So for example, if I just want to get the emails, I can just say, oh, there's no emails actually. If I just want to get the username, I can just say username. If I want to get the username and the password, I can say username and password. And let's run this. And as you can see, it actually worked. I know it doesn't seem like it because we don't have anything in our database, in our table, but you can see it's returning the query, the data, and an empty list. So now let's actually write some code so that it will actually insert data into our database. You can see that the query runs over here. And let's run some code so that it will insert into our database. And then we can check again to see if this query over here is working. But also, if you want to implement TypeScript types over here, what I would recommend is creating interfaces and just putting them as the arguments like this. For example, I would create an interface for user. This is optional, but I would create an interface for user called iUser and just pass it over here. Say like that this function should return a user array. And obviously, this is actually a promise, so you can say that it's returning a promise of users array. And this should work. As you can see, it's not giving any errors. It's just saying that there's no iUser because I'm not going to show how to create interfaces in this tutorial, but this is basically how I would do it. And now let's go here to our mutations folder, or mutations file, sorry, and let's actually create the mutation, right? So we have our arguments over here. How do we actually add or insert to our database? Well, think about this. As I mentioned before, we have to import users here at the top. So import from, and we have to go back to entities like this, entities slash users. And over here, we can just pass users. And then over here, we can very easily just say users.insert and pass an object containing all of the data we want to insert. So that's literally it for actually adding stuff to our database using TypeOrm. It's pretty simple. And we don't even need to pass any we can just grab here and say, okay, I want to insert name, I want to insert username, and I want to insert password. And that's it. This would work. And obviously, when I'm making changes to our database, I like to do this asynchronously. So I'm gonna make this resolve function async, and I'm gonna say that I want to await for the insert statement to be done. And at the bottom, if I want to, I can just return args as I mentioned, but it isn't really necessary. So let's think of this flow. What's happening here? Well, whenever we call this function, we should pass a name, a username, and a password. And it's going to go through the resolve. It should grab the name, the username, and the password over here. And it should actually insert into the users table the name, the username, and the password. We could condense this. We can just actually put here args because we need to pass an object containing exactly this. But I didn't want to do this because I think this way makes it look easier for beginners. So this is basically what we're doing. And we can test to see if this works. So we're going to come here to we're going to obviously open this up and go here to our graphical again. And to make a mutation, it's actually a bit different. So what you do for mutations is you just come over here, you write mutation, then you put the curly braces, you put the name of the mutation, so create user, but then you need to pass arguments. And it already auto-completes the arguments we have to pass. For example, we have to pass name, then we have to pass username, and then we have to pass password, right? And we pass them directly over here. For example, let's create a user with the name Pedro, the username PedroTech, like this, and the password, let's just say something like password. So this is what we're creating, right? And then we also need to pass curly braces after this function, and we put here all of the things that we want from our return. Remember that when we run this mutation, we're returning the arguments back. So we're just returning an object containing name, username, and password. So if you want to see what we put back to see if it's working, we can pass here name, username, password. But again, this isn't necessary. And when we run this query, what should happen is, you can see it actually ran. So let's hope that worked. And it returned the name, the username, and password, which is what we asked for, right? But now let's check to see if it's actually working. Let's come over here to our MySQL workbench and let's refresh our table. And as you can see, a row has been added with all the things that we set in our mutation. And to actually test this if it's working, we can also run a query again for, actually I'll just press Ctrl Z, and let's run the get all users query again and see if we'll actually grab the user. I'll get everything from the user, even the ID, and let's see. And as you can see, it returned an array containing an object containing Pedro, like it actually returning everything from our database. So that's basically it for this video. We're actually going to obviously continue this. I'm going to implement a React front end. We're going to be using TypeScript for React as well. It is a big project, but not an actual large project. It's just that for a tutorial, there's a bunch of underlining stuff and technologies that we're using to help in our development process. This is actually the tech stack that I like to use when I'm building side projects. So that's why I decided to start this series. If you're enjoying the series, please leave a comment down below and tell me if you're enjoying the series. Leave a like because that helps the channel a lot, and subscribe because I'm posting 3 times a week and I would really appreciate it. So yeah, really hope you guys enjoyed it, and I see you guys